Okay, so from there, what they're saying to us, so this is where we are so far with our givens. It says find the ratio of snowboarders on the mountain to all skiers, to all of the skiers and snowboarders. So A, say that we want a ratio of boarders to all on the hill. All right, so, well, first of all, my number of boarders is going to be that 10. This, remember, when they give us a ratio, this is like a sample set. Because chances are there were more than 13 skiers and more than 10 boarders on the hill. There could have been 100, there could have been a lot of them, and this is just a simplified ratio. All right, so we have to use this as kind of like our sample set. Since we want to know the total on the hill, I need to figure out how many there were total in my sample set. So in our sample set, we have a total of 23 skiers and boarders. So my ratio of boarders to all is going to be my 10 to my 23. So that's the first part. Are you cool with that? Okay. So now when I take a look at B, B says use the ratio from part A to find the number of lift tickets sold to snowboarders. All right, well, here's my total. Okay, here's the deal. On the high school placement test, on one of my tests, I would not have given you part A. I would have simply gone right to part B. All right, because you need to be able to use all of this and recognize, oh, I'm dealing with total number of tickets. I'm dealing with total boarders, and then I have a ratio of skiers to boarders. If I was to give this to you, you would have had to be like, oh, wait a second, I need total of my tickets. So I need to have a total from my sample set. That's something that you should have known to do, and that you came up with that ratio because you use it in part B here, that you're going to have to use that. All right, so for part B, they said, use the ratio number 1. We want to find the number of boarder tickets. All right, well, here's my ratio of boarders to all tickets in my sample set. So this is my sample set. This over here is going to be my actual set. So we're comparing our sample set to our actual set. All right. Well, we know that there's a total of 253 lift tickets. I'm going to say all tickets. So the information in my denominators are exactly the same. It's all the tickets. The information in my numerator is going to all be the same. It's going to be my number of boarders. As I was walking around, I noticed that some of you are putting your units on these. That's a really good idea. To make sure that you are lining up the appropriate information together, particularly on ones like this, where the ratio they originally gave us was skiers to boarders. And if you paid attention and put units on there, and you used this directly, you would have known something was missing, something was wrong, because I needed to deal with total number of tickets. So when we started to write this proportion, and you wrote boarders to total number of tickets, you should have been like, oh, wait a second, I just can't use that 13 to 10. I need to rethink what I have to use here because I need total number of tickets. All right, so using units on these is a good thing. So now I'm going to go ahead and just do my cross multiplication. Elle, are you cool with this? Okay, so my cross multiplication says I have 10 times 253 is equal to 23 times x. Everyone should have that part of it. All right, so I have 2,530 is equal to 23x. Divide each side by 23. All right, and I end up with 2530 divided by 23, and I end up with x is equal to 110. What does that mean? What does my answer mean, Giselle? All right, so I might say something like, there were 110 lift tickets sold to snowboarders. Remember, you guys have to remember to write that as a decent sentence. All right, so are you cool with that? All right, do you want me to do C as well? Okay, so it says for C, you know when there's a C, that's always like, oh shoot, now we have a C, right? It says during the same day, the ratio of snowboarders who rented snowboards to those who have their own. So we're dealing with snowboarders. So we have rent to bring, I'm going to say bring, you could have put own, whatever you want to do, is 4 to 7. Find the number of snowboarders who rented snowboards. All right. Well, someone tell me. Let me write this down. What we're looking to find. We want to find the number who rented. How can I use this to do that? How can I use that ratio to find what I'm looking for? Well, let's look at this again. 4 is the number who rented, 7 was the number who brought it with them. How many of you guys agree with that? Okay. I want to know the ratio of rented to the number who rented. What else do I know about my snowboarders? From all that we've done here, what else do I know about my snowboarders? Maya? Yeah, so we know that we have 110 total. So can't I do a similar thing with this ratio, the rent to the bring? Since I'm dealing with a total that I know, what's my total from this ratio? Ashley? That's 11 total. All right, so I can do the same thing I did before. If we have X is the number of rent over 110 total, this is going to be equal to, well, I know that 4 rented out of the 11 total in my sample set. And then you could solve that. Does that help you? Oh, you are not exuding confidence, child. For B, okay. Okay, so let's go back. So this goes back to our original ratio. So what you have to understand when we write these ratios and we simplify them, somebody came up with data and said, this is my ratio of skiers to snowboarders on a day. They probably were, you know, maybe 130 snowboarders to or skiers to 100 snowboarders, right? That's probably more likely what it was. Are you with me on that? Okay. But when I simplify it down to a simplified ratio, it's 13 to 10. 13 skiers for every 10 snowboarders. So for us to use this ratio L in math, we need to think of this as like a sample set. So we have a sample set of skiers, of 13 skiers, to 10 boarders that were there that day. That means that the total number of people in my sample set is 23 people, because 13 plus 10 is 23. This 23 is 13 skiers to 10 snowboarders. Are you okay with that? Okay. The reason I knew I had to find that was, in A, they were looking for the ratio of boarders to all people on the hill. So I needed to come up with, in my sample set, I need to know how many total skiers and snowboarders together there were in my sample set. Do you understand that? All right, so because I needed to write a ratio using that. So my boarders was 10, and all my skiers on my hill for my sample set was 23. So that's where that 23 comes from. Are you cool with that? Okay. So then part B, which is probably what I would have jumped to right away, find the number of snowboard tickets. Well, they told us that we have a total number of lift tickets completely. This indicates that I'm going to use my total number of people on the hill. So I needed to come up with my total number of people on the hill in my sample set too, because these two go together of information. Are you with me? All right. And then the 10 and then what's missing go together with information. So I have my sample set ratio here. I have my actual set of ratio here. Does that help you? Awesome. All right, what else can I do for you guys? Carmen? Sure. All right, so let's take a look at number 25. 25 said, write the sentence as a proportion, solve the proportion. So 25 said, I have x is to 4 as 8 is to 16. Okay. Remember, when we are doing proportions, the reason we can use proportions is because we are comparing two different sets of information twice. One of them we know both of, one of them something is missing in. You guys are listening, please? So here is the relationship that I know. 18 of something is to 16 of something, whatever that is. That could be 18 skiers to 16 snowboarders. Who knows, right? 18 girls to 16 boys. All right? And then we're using that to find the unknown in this relationship. So each of these creates their own ratio. So I end up with x over 4, because I'm just going to use that as it's my first number, I'll put it in my numerator, is equal to, well, 8 was my first number, and the second one was 16 in the denominator. And then I just solve from there. Okay, what else can I do for you guys? Do you guys have any other questions? Okay, this way, get your notes out. Okay, we are not moving away from proportions. All right, if you noticed in the first section, they don't necessarily focus on cross multiplication to solve. Okay, they have you multiply. They just have you kind of like your numerators your numerators where your variable is on each of those. If you noticed on all those, and if you looked at the work they were showing, they were having you multiply both sides by the denominator of the unknown. All right. I don't want to teach you too many ways to do things. So this section here, again, is proportions. So today's 1017. We are doing 2.7. This is proportions. This is where they were actually teaching you cross multiplication. I just do cross multiplication all the time because it works for every single proportion. All right. So these are more proportions. So I'm going to say solving more proportions. The only difference is that now your variable may not be in the numerator. All right, so some of these are going to get a little bit more complex. All right, so let's compare. Let's solve some of these, and I'm going to have us solve some harder ones. All right, so we always solve proportions using cross multiplication. Now, the more proficient you get at this and the more aware you get at different types of proportions written different ways, you may come up with shortcuts, but I don't like shortcuts unless you know how to do it the regular way. All right, so if I have something like 8 over x is equal to 6 over 15. All of you do this, please. I'm going to do this real quick. This is just reminding you what cross multiplication is. It's what we did last night. I hope all of you got 20. You guys cool with the process of cross multiplication? Okay. I'm going to forget to say this to you. This is a little bit out of order, but I'm going to forget to say this to you if I don't say this now. The word proportionate if somebody says to you, prove that this information is proportionate to that information. Proportionate means that the ratios are equal to each other. That's all proportionate means. So if they give you data, if someone gives you data and says, prove that this data, whatever it is proportionate to this data. That just means if you set up a ratio using those data, two of them, set them equal to each other, they are equal to each other. All right, so let's prove. I want you guys to prove if 3.6 over 4.9 is proportionate to 1.7 over 3.2. I want you to prove if they are proportionate to each other. So what you're going to do is you're going to set them up in a proportion. And then we're going to use cross multiplication to see if both sides are equal to each other. I totally made this up, so I would be shocked if they are equal to each other. Like, I would be shocked. I'm not that good, trust me. Not even close. So if you do this cross multiplication, you end up with 11.52 is equal to 8.53. How many of you guys got that? So what this says, this is not true. They are not equal. So what this means is, I'm going to say, so 3.6 over 4.9 is not proportionate to 1.7 over 3.2. That's what I've just proven, okay? So if you're in your homework, they ask you to prove if two fractions or two sets of data are proportionate to each other, you're creating the ratios like we normally would. You're setting them equal to each other. You're using your cross multiplication to see if the left side equals the right side. Okay? Yeah. I do. I want you to tell me what your conclusion is. If you say not true, so, or no, the fractions aren't proportionate to each other, something to indicate what you just found as your conclusion. Does that make sense? Okay. All right, so I wanted to make sure that I got that out of my head and on the paper because you might be asked that. Okay? All right, so let's look at a funky looking proportion. Some of these we may have done last year, but it's always worth going back over again to have you guys master it. So I want you to solve 4 over x is equal to 8 over x minus 3. All right, here's the thing I want to point out to you. Although here you probably wouldn't do it, I want to make sure I tell you this. You cannot DOCF across equal signs. Now on this one you probably wouldn't have thought to anyway, only because the 4 and the 8 are both in the numerator, but I want to make sure I tell you that again. You cannot divide out common factors across equal signs. All of you finish this. One thing I want to point out to you is you have to multiply that 4 times the entire x minus 3. So what should I see in your next line when I show that multiplication? Rafaela? Yeah, I should see the distributive property. Either distribute it right away, which I'm okay with in this class, or show 4 times the quantity of x minus 3. All right, that's probably the better thing to start with, is with the parentheses, and then show your multiplication. How many of you guys got negative 3? Yeah. Do you guys remember doing these last year? A little bit? Kind of? Maybe? Okay. So I'm not going to dwell a lot on those because those are not always the ones that we're going to be having troubles with. All right. I do want to talk about scales. So let's talk about scales. Where do we see scales? Where might you see a scale? Natalie? A blueprint. Where else might we see a scale? Maya? On a map? On a blueprint, we might have 1 inch equals 3 feet. On a map, we might have 1 centimeter is equal to 100 kilometers. Typically in a scale, we have a 1 this is the map or drawing measure. All right, and then we don't have 1 usually. It's some other number as our actual measure. It is possible that someone may say to you on a drawing 2 inches equals 9 feet. Right, you can come up with a scale for there. You could use that. Scales typically have 1 as their map or drawing measure. Okay. So the other thing I want to point out to you is when given a scale, use the scale as your known ratio. Use your scale as your known ratio. It's going to make life considerably easier if you just write that scale down. Okay. So let's say, for example, the distance on a map from Cincinnati to Cleveland is 4.2 centimeters. So the distance on a map between Cincinnati and Cleveland is 4.2 centimeters. The scale on the map is 1 centimeter to 85 kilometers. What is the actual distance from Cincinnati to Cleveland? All of you do this. Somebody write my proportion for me. All right, Giselle, go ahead. Excellent. Okay. Okay, and then what would you write as your answer, like a statement? Excellent. The actual distance from Cincinnati to Cleveland is 357 kilometers. And I'm okay with using abbreviation for kilometers. You guys cool with this? How many of you guys are pretty confident with, a little bit more confident with your proportions? Okay, if the ratios ones throws you off, then practice some more of the ratios ones versus the scales ones. You know what I mean? Okay. We can just sit and relax. We have about 2 minutes. So you guys can just start on your homework if you want. You can sit and relax, whatever you want, for about 2 minutes. Yes? You do not need a game plan for proportions. If it helps you to have a game plan for proportions, you do not need a game plan for proportions. You can do it if you'd like to. I don't require it. I kind of feel like putting the units on them is kind of part of, you know what I mean? That kind of helps with what a game plan would do. I do not. It's a good question. Thank you.